Hello friends, we will discuss today the equivalence of CFG and PDA, context-free grammar and PDA. In this particular lecture, in couple of lectures, we will complete this topic. In this lecture, I will convert CFG into PDA, and then in next lecture, we will discuss PDA into CFG. First, I will discuss CFG into PDA. So, I will mention it as like this, CFG to PDA. Now, as you know friends, CFG is a grammar. CFG is a grammar, and context-free grammar, as it is grammar, so it will have four tuples: V, then T, then P, then S. And PDA is mathematical model which is having seven tuples. So which are Q, then sigma, then delta, then gamma, then Q0, then Z0, then F. So all these seven tuples we are having in PDA. Now, as we are converting CFG into PDA, so these four tuples are being converted into these seven tuples. So how this mapping would be done, that I will explain. But before this, I will tell you something about PDA. So when we are converting any grammar into PDA, so we will create PDA which is accepting strings by empty stack. And if it is accepting strings by empty stack, then there will not be any final state. And in this case, final set of final state would be phi. So I can write here phi simply phi, right? And then when we are converting grammar into PDA, so this Z0 would be any star symbol of grammar would be used as initial stack symbol. So I can write here S. When we are converting any grammar into PDA, then we can use only one state. We need to use only one state, which we will use as Q. So this capital Q would be having only one state, which is Q, and as it is having only one state, so initial state would be Q only. So in this case, Q0 would be Q. Q0 would be Q. Now that delta, we will create transition for this. So I will discuss it later. Now all the terminals of grammar would be converted into input symbols. Now what would be the gamma? So this is very interesting. Suppose friends, when you are converting any grammar into PDA, so now this grammar may be in two different forms. It may be in GNF, it may be in GNF, or it may not be in GNF. So as we have studied two normal forms of the CFG, which are GNF and CNF. So GNF are generally implemented with a PDA. For PDA kind of implementation, GNF is a very useful normal form. So if your grammar is in GNF, then it is very easy to convert it into PDA. So you can say GNF is PDA friendly normal form. So now in case when you are converting any grammar into PDA, so there are two possibilities. Your CFG may be in GNF and may not be in GNF. So these two possibilities are there. Now I will discuss first possibility is GNF. So now when your grammar is in GNF, so you will store all variables of the grammar into stack. So gamma would be mapped to capital V. Gamma would be mapped to capital V. Now, when your grammar is not in GNF, then in that case, so here I can write when grammar is in GNF, then all these seven tuples would be like this. Now I can write again all 7 tuples when grammar not in GNF. When grammar not in GNF. So again we will use only one state. So this would be Q only. Then terminals would be input symbols of PDA. Then delta would be, we will define it. Then this gamma would be V union T. You can, when grammar is not in GNF, you can store both terminals and variables into stack. So gamma would contain the union of variables and terminals. Then this, as there is only one state, so only this would be the initial state. Then start symbol will be considered as initial stack symbol. And as we are creating PDA accepting strings by empty stack, so final state will not be there. So this set would be phi again. So this is how all these 7 tuples would be mapped to VTPS. So I hope this mapping would be very much clear. Now I will take the one example of both the grammar, and I will tell you how to convert that particular grammar into PDA. So now friends, this is one example grammar. This is already in GNF as you can see here. So now friends, I will tell you general rule that how to convert any particular production which is in GNF into transition. So if you have any production like this, A gives A alpha, where alpha is any string of variable. So this production is already in GNF. Now, how to convert this particular production into PDA transition? So I will tell you. So you are in state Q. You are reading the symbol here. This will come here A. This will come here A. Stack top is considered, current stack top is considered as left hand side variable of production. And then this combination will give you, again you will be in same state Q, and you will insert this string of variable into stack. And remember friend, whenever we are inserting some element into the stack, generally we also write current stack top in the right hand side. But here you can notice we are not writing A here. That means first we need to remove this A from a stack, and then we can push this alpha into the stack. So this is how this kind of production rule is converted into transition. Now I will take this grammar as an example, and I will tell you how this particular grammar would be converted to PDA. So now we can use this rule and we can convert all production one by one into the stack. Into the transition. So now I'm in initial state Q. I'm reading A, and current stack top is S. Then what I can do, I can stay in Q. And I can push this remaining string into the stack. Now I will convert this particular production into transition. Now you can see, as it is for this production is also for S. So this now what would be the combination for this? So now you can see you are in Q, you are reading this B, and you stack top is S. Then what you can do? You can stay in Q and you can push A into the stack. Now we have converted both the production of S into transitions. Now I can convert all these productions also. So I am in Q, I am reading B again. This time stack top is A. So what I can do? I can stay in queue. I can push that B into stack. Now this. So I'm in queue. I'm in state queue. Then I'm reading A. Then current stack top is A. So now here we do not have anything after A. So we can consider here as epsilon. So I can stay in queue, but epsilon I can mention here. So this means we are popping one element from the stack. So this is how these two productions you can convert into corresponding transitions. Now I will convert these two productions into transitions. So now I am in Q, I am reading A and the current stack top is B. So this will give us, I will stay in Q and I will push this A into the stack. Now for this particular transition, so I am in Q, I am reading B and the current stack top is B again. So now I will stay in Q and as it is nothing there after B, so I can write here as epsilon. So this means we will on this combination we will pop one element from the stack. So we have converted all these production rules into corresponding transitions. So as you can see, my friend, all combinations in this PDA are having only one next state. So this is DPDA. So this is DPDA. This is deterministic PDA. Now I will tell you one condition where you will get NPDA. So I hope it would be very much clear to all of you. Now I will make little change in this particular grammar. So now suppose there is one more production as gives A. So now I can convert this particular production into transition. So I am Q, I am reading A and stack top is AS again. And this condition I can stay in Q and as nothing is there after A, so I can mention here as epsilon. So now we have two transition for same combination QAS. So for these two transition we have same combination. So this is one kind of NPDA. So whenever you are having two productions starting from same symbol, then the corresponding PDA would be NPDA. And now I will tell you how to accept any string generated from this grammar by this PDA. So now friends, I will take one example string here. So I'm taking here as A, B, A. This string is valid, this string is generated by this grammar. And let's see how this particular string will be accepted by this PDA. So now I will tell you how this process is done. Now I have this string and as I told you, a star symbol of grammar will be considered as initial stack symbol. So S we will put into the stack first and then I'm in state Q. I'm reading A here and stack top is S. So I have this particular combination. So according to this, what I will do, I will stay in Q and I will push these two symbol into the stack. I will push these two symbols into the stack. Now, as I am not repeating this current stack top here in the right hand side, that means it will be removed first from the stack. And then these two symbols will be inserted into the stack. But remember friend, when we are inserting these two symbol, this string into the stack, So we will start from right hand side. So this will be uh, first this right hand side symbol will be inserted, then next symbol will be inserted. So this alpha is reverse. This alpha is inserted into the stack in a reverse order. Suppose alpha is A B A. Sorry, A B C. A B C. So the C would be inserted first, then stack would be like this: C, then B, then A. So that A would be the current stack top. So this is how this string is inserted into the stack. So now here we will now push these two B into the stack. Now I'm in Q again. I'm reading B and stack top is B. So I'm in Q. I'm reading B and stack top is B. So what I can do? I can pop one element from the stack. So I can pop this B from the stack. Now I'm in Q again. I'm reading A and stack top is B. So I'm in Q. I'm reading A. I'm reading A and stack top is B. So I can push A into the stack. But before this, I need to remove this B from the stack. So I will remove this B and I will push A into the stack. Now I'm in Q, I'm reading A again and stack top is A. So I'm in Q, I'm reading A and stack top is A. So what I can do, I can remove this A from the stack. So now after reading complete what we are we are having empty stack. We are having empty stack. So this is how we have got accept this string. So I hope friend it would be very much clear. Now I will take one example grammar which is not in GNF. So now this grammar is not in GNF. So now friend, when we are getting any grammar which is not in GNF, so we can convert it in some different way. When we are having any variable on top of the stack, then we will not consume any input symbol and we will read epsilon only. We will read epsilon only. And if we are having any terminal on stack top, then we will consume one input and we will work according to the transition. So now how I will do it, how I can write production for this, so I will tell you. So now here for all productions I will write some transition rules. So as I told you friend, we are using only one state here which is Q. So I will be in Q. I will read epsilon and S is on the stack top. So what I can do, I can write, I can stay in Q and whatever is the right hand side, I can push this side into the stack like this. And same thing I will do for this. So I'm in Q, I'm reading epsilon again and stack top is left hand side variable. So I can write here, I will stay in Q, I will push AB into the stack. So this is how I have converted both the production of S into corresponding transitions. Now for A. Now as I told you, I'm using only one state, so I will be in Q. As A is also variable which is considered as current stack top, so I will not consume any input symbol and I will read epsilon only and the stack top is A. So now what I will do, I will stay in Q, I will push this right hand side string into the stack. And then here also, so I'm in queue, I'm reading epsilon again, I'm stack top is A, capital A, so I will write, I will stay in queue again, and I will push this C into the stack. Now I have converted all production into corresponding transitions. But is this PDA complete? No, it is not. So for all of the terminals, we need to add rules like this. So I'm in queue, I'm reading A, and stack top is A. So what I can do here, I can stay in queue, I can pop one element from the stack. For all terminals, we need to make this transition. So I'm in queue, I'm reading B, I'm stack top is B again. So what I will do, I will stay in queue, I will pop one element from the stack. Now one more terminal is there. So I'm in queue, I'm reading C, and current stack top is C. So what I will do, I will stay in queue, I will pop one element from the stack. So now this all these transitions of PDA are complete now. So first we need to convert all productions into corresponding transitions without consuming any input symbol. And then for all terminals, we need to write some transitions like this. Now, I will tell you how this particular PDA will accept all strings generated by this grammar. So now you can see one string is, I can take one string, example string from this grammar, and I will show you how this PDA will accept this string. So now friends, this is one example string from this grammar, and I will show you how this particular PDA will accept this string. So as I told you, star symbol will be the initial stack symbol. So I have put one S there into the stack. Now, as S on the stack top, so we will not consume any input. I'm in queue, I'm reading epsilon, and stack top is S. So with this, we have two choices for this uh, combination. But with this, I cannot generate this string. With this, I can generate this string, so I will use this transition. So I will stay in queue. I will stay in queue. I will pop this S from here, and I will post this string in reverse order into the stack. So this B, A, and A. Now you can see I'm in queue. I'm reading A, and the stack top is A again. So now, according to this rule, what I can do, I can pop this element from the stack. And whenever we are popping one element from the stack, we will consume this input symbol. So now we are in queue again, and now we have consumed this A, so we are reading C. We are reading C, but stack top is A. So whenever stack top is capital A, that means a variable. So now if variable is there on the stack top, we will not consume any input. So what we will do, we will read epsilon, stack top is A, we are in queue. So with this, we can, again we have two choices here. This is basically NPADA. So we have two choices again. So with this choice, I cannot generate the system, but with this choice, I can generate the system. So I will use this choice. So with this, what I can do, I can remove this A first, and then I will push this string into reverse or into stack in reverse order. So I can push A, then I can push C. Then I'm in queue, I'm reading C and small c, and small c is on the top of the stack. So according to this, I can pop this C from the stack. So I can pop this. Now, as I am popping one element from the stack, so I can consume this input. So I am reading this C now. Now, again, I have A on stack top. So I will not consume any input. So again, I can use this transition. So I'm reading epsilon, I'm in Q, I'm reading epsilon, and stack top is capital A. So what I will do, I will remove this A and I will push CA into reverse order, into stack in reverse order. So this would be the stack situation after this. So now I'm in Q, I'm reading C, stack top is C. So according to this rule, I can remove this C from here, and as I'm removing some element from the stack, so I can consume this input. Now I'm reading this C. Now I'm in Q, I'm reading C, and I'm stack top is capital A. Very well. I will not consume any input. So I can use this transition again. Now, sorry, I can use this transition. I can use this transition now. So according to this transition, what I will do, I will remove this A from here and I will push C into the stack. Now, I'm in Q, I'm reading C, and the stack top is C. So according to this rule, I can pop this element from the stack. As I'm popping one element from the stack, so I can consume this input. So I'm reading this B. So I'm in Q, I'm reading B, and stack top is B. So according to this, I can remove this B from the stack. And then after this, nothing is there. This is the last symbol. So after reading complete string, as stack is empty, so I can consider this string as accepted by the PDA. So this is how this particular PDA will accept all strings generated by this grammar. So I hope it would be very much clear to all of you. And still, if you have any doubt, you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.